Hello, the topic of today's class is algebra, introduction to algebra. Let's consider some patterns. Jeremy has 5 tiles numbered 1 through 5. Imagine he has 1, 2, 3, 4, and 5. He has to arrange these numbers such that they add up in the same number horizontally and vertically. For example, we already have an example. Horizontally, 4 plus 1 plus 3 equals 7, and vertically, 5 plus 1 plus 2, 4 plus 1 plus 3 equals 8, and 5 plus 1 plus 3 equals 8. Now take a look at the second arrangement. Horizontally, we have 4 plus 3 plus 2, 9, and vertically, we have 5 plus 3 plus 1, also 9. Notice each time we pick a different central tile or number in the middle. So we already have these two examples, right? The number in the middle is 1. The number in the middle is 3. Now, what other number can be in the middle such that the numbers left to right and up and down add up to the same number? Well, my friends, I hope you're spotting something. What if we choose 5 to be the number in the middle? Let's see. 1 plus 4 gives you 5. 2 plus 3 gives you 5. So you can arrange 5 in the middle and then say 2 and 3 on the top and 1 and 4 side to side. So again, you will have 10 going up and down, and the sum is 10 going left to right. Now let's consider a different example. What if we have tiles 2 through 6, still 5 tiles? Let me write them down. 2, 3, 4, 5, and 6. I hope you're trying to understand this. If I choose the central tile, the tile in the middle to be, here the tile was number 5, the tile in the middle to be number 2. Let's consider this. If the tile in the middle is number 2, then the 2 tiles surrounding it can be 3 and 6 because they add up to 9, and also 4 and 5. They also add up to 9, such as this, right? 2 is in the middle, 3 and 6 going up and down, and 4 and 5 going left to right. So we would have 9 plus 2, the sum would be 11. Now let's consider a different tile in the middle. What if the tile in the middle was 4? Let's write it down. What if the tile in the middle we choose to be was 4? Well, let's see. We would arrange the tiles side to side, can be 3 and 5 because they add to 8, and up and down could be 2 and 6. They also add up to 8. So 8 plus 4, it would be 12. And of course, guess what? The last tile in the middle that we are going to choose, look at the pattern. 1, 3, 5, that is for tiles 1 through 5, right? 2, 4, I suggest we try 6. If the tile in the middle is 6, which pairs of numbers add up to the same sum? Well, I see it. 2 and 5 make 7, 3 and 4 make 7. So it would be something like this: 6, 2 and 5 on the side, and 2 and 5, and 3 and 4 top to bottom, for example. So the full sum would be 13 going up or down. I will let you continue with these patterns if you have different tiles with different arrangements. And in the meantime, let's continue going to the following page. My friends, algebraic expressions. We've seen algebraic expressions at the end of grade 5. If you wish, you can listen to the videos in textbook 5, 13.2, 13.3. Algebraic expressions, we call them mathematical sentences. Sentences that are made up of numbers, variables, not always, but often, variables, and operations. And operations can be all types, including parentheses, right? So these are mathematical sentences or phrases. mathematical sentences. But one thing expressions do not have. They do not have equal sign at the end. So they're like open phrases without punctuation. So let's take a look. We have a girl Amelia and a boy Ben. Amelia says, I have 1 apple. Ben says, I have 3 more apples than Amelia. I have 4. If Amelia has 1, Ben has 3 more, which is 4. We've seen this representation. The difference between Ben and Amelia is 3. Amelia has fewer. Ben has more. Now, we've seen this in 3rd grade. This is like pictorial representation, right? We're looking at bar models. Here we have a little table. But let's summarize it. Ben always has 3 more apples than Amelia. If Amelia has 1, then Ben has 4. If Amelia has 2, and the rule is always plus 3, right? He always has 3 more. Of course, she has 5. If Amelia has 10, Ben will have 15. If Amelia has X, Ben has X plus 3. Look at. Of course, she has 13, and he has X plus 3 again, which is an expression. This is what we call an expression. It's not an equation. There is no equal sign. It's just a mathematical sentence, mathematical statement. So we can use X to represent the number, and we can express Ben's apples in terms of X. So again, the difference is plus 3 for Ben. Ben has 3 more, Amelia has 3 fewer, and so on. Let's practice. I call it translate from English to algebra. Let's go. Carl is Y years old. Kimi is 2 years younger. Kimi is Y minus 2. If Carl is Y, Kimi is Y minus 2. Now, Carl is older. He is Y years old. Kimi is younger. She is 2 years less. So, Y minus 2. We expressed Kimi's age in terms of Y. In other words, we use Y in an expression. Now, next example, Ken says, I have X dollars. But Yana says, I have 3 times as much. How do we translate 3 times as opposed to 3 more in mathematics? We say 3 times X. For example, if Ken has X dollars, Yana has X 1 time, X 2 times, X 3 times, or we write it as 3X. Now, again, look at this language of algebra. Express in terms of X. In other words, translate the situation from English or from the picture using X in your expression. So, the basketball weighs X kilos. It is the same as 4 baseballs because look, they're in the balance, right? So all 4 baseballs also weigh X kilograms. The weight of each baseball is, sometimes we would say X divided by 4. In other words, we can say X over 4, which is the same as to say 1/4 of X kilograms. And I would say this is the preferred way in algebra language. We put the coefficient, let me highlight this. We put the coefficient, which is a fraction, we put the coefficient in front of the variable. Coefficient. It's a number that tells us multiply X kilograms by 1/4, which is the same as divide by 4. Now, let's consider more examples. I am on page 13 of our textbooks. Page 13. These are very good examples. Earl has 4 more dimes than quarters. Now, I want you to think about this one small sentence, and let's consider this. Earl has what? Dimes and quarters. What does he have more? He has more dimes, so we can draw a longer bar for dimes and he has fewer quarters. What is the difference between dimes and quarters? This difference is 4 more. If Earl has 10 quarters, how many dimes does he have? Dimes would be 10 plus 4, right? Because he would have 10 quarters, and we have 4 more dimes. If Earl has 10 dimes, so we would say quarters equals 10 dimes minus 4, because he has fewer. I'm going to erase this. He has fewer quarters, right? What's the difference? 4 fewer. If Earl has 10 dimes and quarters, now this is a harder problem to solve. Let's tackle this. If Earl altogether has 10, how do we find how many coins of each denomination does he have? We've solved these problems in 3rd and 4th grade. Step 1, remove the difference. So we would say altogether 10 minus 4, and then divide by 2. And that would be the quantity for quarters. And for dimes, let's compute this. This would be 3. So each of these pieces would be 3. So then the dimes are 3 plus 4 equals 7. Okay? Now, by the way, I never answered them. 10 plus 4 equals 14. 10 minus 4 equals 6, of course. 6 quarters. Now let's consider the next example. Ken has 4 more dimes than quarters. The same picture. Ken, now instead of Earl, Ken has, look at the language. It's pretty much the same as above. Earl has 4 more dimes than quarters. Ken has 4 more dimes than quarters. Pretty much the same picture, right? So we can say dimes and quarters. We have more dimes. We have fewer quarters. What's the difference? The difference is 4. Now, if Ken has 12 quarters, how many dimes does he have? I hope you're realizing this is still 3rd grade problem. He has dimes equals 12 plus 4 equal 16. If Ken has 12 dimes, this part is 12. I hope you realize that for him to have 12 dimes, the quarters would be fewer. So it's 12 minus 4. He would have 8 quarters. Now, again, the same question. Look at the similarities. If Ken has 12 dimes and quarters altogether, if Earl has 12 dimes, look at the patterns. If he has 12 altogether, the way we would compute each part, we would step 1, get rid of the difference, 12 minus 4, divided by 2. And that is 4. This piece is 4, this piece is 4, and that is number of quarters. And the number of dimes would be 4 plus 4, which is equal to 8. Now, the algebra